Hello, Algebra 2. Here we go again. Given all the flu that's going around and breaking down the walls, I thought I would do some videos for those who maybe have missed class here and there or just need a little bit of a review to catch up. So this video is about 6.5, the property of logs. This is the section the substitute went over with you, but we did review in class, so I'm going to review this with you now. So when you have a logarithm, there are two things we can do. We want to be able to expand it so that we simplify the argument that comes after the log. The purpose for this is mostly in calculus. For us, we also want to be able to condense two or more logs into one log, because you need to do that in order to solve a log problem. So let's go through these properties, and they mirror the properties you would use with exponentials when you're either multiplying or dividing their base. So if I have log in this first one, the product property, if I have a product in my argument, log base b of m times n, I can expand, so going in this direction you are expanding so that each element in your argument gets its own log. So we get log base b of m plus log base b of n. So if you are multiplying the terms in your log, then you expand it with addition. So for instance, in the example we have here log 8 times x, so it gets expanded into log 8 plus log x. So multiplication goes with addition. And then the quotient property, if you are dividing the two elements in the argument, well, that division symbol kind of looks like a subtraction symbol. You can think of it that way. It's also like when you are dividing common bases in an exponential, then you would subtract each element. So log m divided by n is going to equal log m minus log n. So here we have x over 16. It can get expanded into log x minus log 16. So division goes with subtraction. And it also goes backwards. If you see two logs and want to condense it into one, if they are joined by subtraction, then you divide the two arguments. If they're joined by addition, then you multiply the two arguments. Our last property here is called the power property. And this is where you can take this m raised to an exponent of n. That n can travel down in front, or sometimes it's also necessary for that n as a coefficient to travel upstairs as an exponent. That is called our power property, because often we don't want a coefficient in front of our log. So I can take that 3 and move it upstairs so that we have log base 2 x cubed. Okay, those are our three properties that we want to use when we are expanding or condensing. So let's look at how this works. So in this first problem, notice we have natural log 5x to the 7th over yz. So we have both multiplication and division going on. So I'm going to do this step by step. We're going to focus on this division here. That means I'm going to write natural log 5x to the 7th. Division becomes subtraction, natural log y times z. Now I still have multiplication going on here. So, and I have multiplication going on here. So the first step is I'm going to now expand ln of 5. Since this is multiplication, it's going to become a plus ln x to the 7th. And in the second term, now we have to be careful because there's a minus here, so I'm going to put a parenthesis like this. And now we expand, so it's ln of y plus ln of z. So notice multiplication becomes addition, and everyone gets its own log. We're almost there. Our last step is we are going to move any exponents down in front, and we're going to distribute that negative. So our final answer will be ln of 5 plus 7 natural log x minus ln of y minus ln of z. So notice every argument of your log is just one number or a variable with no exponent. It's as simple as it can be. Also, as a shortcut, you can kind of skip this middle step. If you notice, anyone that was in the numerator is going to be positive. Anyone that was in the denominator is going to have a negative in front of that term. So that's kind of a little shortcut you can take. All right, so that would be expanding. Let's look at what we do when we're condensing. So we're going to work in reverse. The first thing we do is take any coefficients, and they're going to go upstairs, so this will become a 3 up here, 2 cubed. Now I have addition here. So what happens when you're condensing is it's one log. You're condensing into one log. So never, ever, ever will you have more than one log in your answer when you're condensing. So I'm going to put a big parenthesis here. Let's see how this works. I have two terms that are positive, so they're going to go together on top as multiplication. So 9 times 2 cubed, which is 8. And then the terms that have a negative in front of them, minus log 3 minus log x, they will be joined as division, so they go in the denominator. Sorry about that. So 3x will go down here. And the reason why that got multiplied, I'm kind of taking a shortcut here because this is really log 3 if I factor out that negative plus log x. So the log 3 times x goes in the denominator. That minus told us to divide. And now I can simplify this. So I can simplify 3 goes into 9 3 times. Your final answer will be log 24 over x. So that's how you expand or condense. Now an application of this, and this is quite common on the ACT, SAT, this is how they test you on knowing your properties of logs without using a calculator. They give you some clues. So we have log base 2 of 3 equals 1.585, and we have log base 2 of 7 equals 2.807. Now the other property you should always write down, they won't give it to you because they expect you just to already know it, is log base 2 of 2 equals 1. So notice these all have the same base. What you're going to do then is you're going to rewrite the given term using your expansion properties, and that is what I want to see. I want to see the expansion property. I care about that more than your decimal answer. So here we have log base 2, 3 divided by 7. So I can expand this using subtraction because that was division. So log base 2, 3 minus log base 2, 7. The rest now is just substituting in the given decimals. So log base 2 of 3 was given as 1.585 minus 2.807. And when you subtract those together, you will get negative 1.222. But what I really want to see is that, and then you would give your final answer, okay? Log base 221, now here it's a little more, you have to use a little more creativity to figure out how do I take log base 2, 3, log base 2, 7, and get log base 221. Well, that works because 21 is 3 times 7. So since that's multiplication, I can expand it using addition. So now that I have that expanded, I can then substitute in 1.585 plus 2.807, and adding those two decimals together would give me 4.392. All right, again, you want to show that expansion property that you used. Now this last one, 343 might not seem really obvious at the start, though you did have a whole chapter on using exponents. Turns out that 343 is the same thing as 7 cubed. So I can start by writing 7 cubed, but we can't have an exponent here. So we're going to take that 3 and use our product property to move it in front. So 3 log base 2 7 is how I would expand that. And then substitute log base 2 7 is 2.807. So you're multiplying that by 3, which will give you 8.421. All right, so that's how you can utilize those log properties to expand and substitute and get a decimal answer without a calculator. Now, speaking of without a calculator, we have something called the change of base. The purpose of the change of base is so that you can enter a log into your calculator, because your calculator, the older ones especially, only understand base 10, the common log, or base E, your natural log. And so, and I realize this may be kind of dated because some of the newer calculators will do the change of base for you, but until that's a little more universal, sorry, we want you to be able to use the change of base. Now, how does this work? So you can rewrite a log with any base you want, but the way it works is you're going to write, the subscript will go downstairs with whatever new base you chose, and your argument will go upstairs. If it's a natural log, same thing. Your subscript will go downstairs now with a log base E, the natural log. A will go upstairs. Now you could plug it into your calculator and get a decimal answer. So let's go ahead and do this. We have log base 3 of 8. So we're going to write it as a common log. Remember, that means base 10, which you don't actually have to write the 10. Remember, that's our default, but I'm just going to emphasize it right here. And so the subscript 3, the base, goes downstairs as a base, and the 8 will go upstairs, and that is your answer. And again, you don't have to write the 10. It's also okay just to write your final answer like this. But the joy of that is now I can go to my calculator and go log 8 divided by log 3, and you can come up with a decimal answer of what that represents. Same thing for your natural log. So that's what this works here. So you're given log base 6 of 24. So I write natural log on top, natural log on bottom. So the subscript is going to go downstairs. The argument goes upstairs. And I could now go to my calculator and do the natural log of 24 divided by the natural log of 6, and that would give me 1.774. Now on the test or a quiz, I actually prefer this exact answer, because anybody can then just go to a calculator and hit numbers. So you are going to want to show the change of base, not just enter it in. All right? And I hope that helped. There'll be a couple more videos following.